Why does this seemingly cold and desolate planet make everyone feel uneasy? Pluto. It was once thought to be a lifeless, frozen world, but now it has been discovered to hide ice volcanoes, oceans, and even signs of life. Why is it still so mysterious when it is so far from the sun? What is even more surprising is Arakos. Near Pluto, they may hold the key to major mysteries about the origin of the solar system. Pluto and Arakos, these two distant objects, seem to hide astonishing secrets we never imagined. In the next few moments, let us explore the truth behind these celestial bodies together. In July 2015, NASA's New Horizons spacecraft flew past Pluto, completely overturning our previous understanding of Pluto. Pluto is not the cold, lifeless sphere we once imagined. Instead, it is a world full of complex landscapes and vitality. One of the most astonishing discoveries is the vast network of ice volcanoes on Pluto, or to be more precise, they are cryovolcanoes. Unlike anything else in the solar system, these ice volcanoes exist. It has overturned our understanding of this dwarf planet. In March 2022, with more detailed data analysis, scientists discovered that along the edge of the heart-shaped bright region in the southwestern quarter of Pluto, there are actually enormous dome-shaped mountains. Their surfaces are covered with rough textures. One of them, called Right Mons, about 3 miles high, spanning 90 miles across, its volume is comparable to Mauna Loa volcano in Hawaii on Earth. Nearby, there is another massive dome called Picard Mons. They are not volcanoes, but rather ice volcanoes. Instead of erupting lava, these ice volcanoes spew a mixture of water, methane, and other volatile substances, seeping out slowly like a half-frozen glacier. Sights on Pluto are undoubtedly even more breathtaking. Yet the most astonishing thing about these cryovolcanoes is how young they are. There are almost no impact craters around them, which indicates that these ice volcanoes formed in the recent geological past. They may be only a few 100 million years old, or even younger. On the timescale of the universe, it all happened in the blink of an eye. Some scientists even believe that this region is still active today, slowly reshaping itself. Semi-frozen lava is seeping out from Pluto's interior. These discoveries have dramatically changed our understanding of Pluto, but this activity is also truly puzzling. It is so small, only 2/3 the size of the Moon, and it is so far from the Sun. Logically, its internal heat should have dissipated long ago, but the discoveries made by New Horizons completely overturned this assumption. The existence of these giant ice volcanoes shows that Pluto still retains enough energy. Geological activity supports it. It even continues into the late stages of its life cycle. This discovery has forced scientists to rethink how dwarf planets operate. And what is even more puzzling is, what heat source inside Pluto is still driving it. Some scientists believe this heat comes from radioactive elements in Pluto's rocky core. Others speculate that there may be antifreeze substances inside Pluto, such as ammonia, which can keep water in a liquid state and prevent it from freezing, regardless of the heat source. Ice volcanoes on Pluto have become clear evidence, proving that this distant planet is not completely dead. When New Horizons flew by Pluto, scientists also discovered huge cracks and depressions on Pluto's surface. These structural features reveal the dynamic changes happening inside Pluto. Pluto's icy shell seems to be stretched and torn apart by forces from beneath the surface. Scientists believe these cracks are most likely signs of Pluto's underground ocean slowly freezing. Although it sounds incredible, Pluto may actually be hiding a liquid water ocean tens, or even hundreds of miles beneath its frozen surface. You might be wondering, how is that possible? Pluto is so cold, how could water possibly stay liquid? Actually, the key to all this lies in the expansion of water. When it freezes, it is just like a water bottle bursting in the freezer. If Pluto's underground ocean is gradually freezing, its expansion would push against the surface, causing the ice crust to crack. In fact, images show that Enceladus's ice shell has been stretched and fractured over long periods of evolution. However, there is no evidence that this subsurface ocean has ever completely frozen. If it had fully frozen, the water would have formed a dense type of ice, called ice under high pressure. This ice would shrink in volume and left behind traces of compression. For example, the shell layer collapsing inward, but New Horizons did not find any signs of such compression. All these discoveries led us to speculate there might still be liquid water beneath Pluto's surface, as Dr. Alan Stern, principal investigator of New Horizons, said. Deep inside Pluto, how could it be possible at a surface temperature near 382 degrees Fahrenheit still retains liquid water? Scientists explain that Pluto's core and mantle may still preserve heat from its early formation, and this heat is retained by insulating materials. Recent studies have even found that there may be a layer of carbohydrates at the base of Pluto's ice shell, a mixture similar to ice and gases like methane. This layer of hydrate acts like an insulating blanket, slowing down the loss of heat and keeping the ocean warm. In addition, the ammonia in Pluto's water also acts as an antifreeze, allowing the water to remain liquid at extremely low temperatures. All of this suggests that Pluto is not just a simple frozen world. Instead, it is a planet with an ocean, although its ocean is sealed beneath a thick layer of ice. This concept puts Pluto on the same level as Europa, Enceladus, and other ocean-bearing moons. The only difference is Pluto's ocean does not have a giant neighboring planet to exert gravity and heat it. A 2020 study proposed a startling hypothesis. Pluto may have formed through a hot process. A powerful impact could rapidly release enough energy to melt the internal ice and directly form a liquid ocean. If that is the case, Pluto's ocean may have existed for over 4 billion years. This discovery makes us rethink Pluto's dynamism. It might be more active than we imagined, and even more likely to support life. Meanwhile, the thin atmosphere above Pluto has also attracted scientists' attention. This faint blue haze, made up of nitrogen and a small amount of methane, is thin and short-lived. It is another astonishing discovery by New Horizons. The spacecraft captured Pluto's sunrise and sunset, revealing the glow of this blue haze. As Pluto approached the Sun, its atmosphere expanded. When Pluto neared the Sun in 1989, frozen gases are heated and sublimate, causing atmospheric pressure to increase. According to observations from Earth, from 1988 to 2016, Pluto's atmospheric pressure increased by about 3 times as more nitrogen entered the atmosphere. However, as Pluto gradually moves away from the Sun along its 248-year orbit, this trend is reversing. 2019, astronomers made a startling measurement by observing stellar occultations. They found something remarkable. Since 2016, Pluto's atmospheric pressure has dropped by more than 20%. Another occultation analysis in 2018 confirmed that the atmosphere is indeed thinning. Pluto's nitrogen is beginning to freeze, forming frost that falls to the surface. If this phenomenon continues, Pluto's atmosphere is very likely to start collapsing. Andrew Cole, who studies Pluto's seasonal changes, predicts that by the 2030s, Pluto's atmosphere could almost completely freeze. It would condense into an icy layer, especially during the long, cold winters. When the northern hemisphere is plunged into darkness, temperatures will drop to extremely low levels. The remaining gases will settle on the surface as nitrogen and methane ice. As the atmosphere gradually freezes, Pluto may turn into an airless, frozen sphere. Pluto's sky will become clear and cloudless, with only occasional signs of vapor near areas illuminated by sunlight. Fortunately, this process is not a permanent disaster. As Pluto continues along its orbit, hundreds of years later, when the South Pole turns toward the Sun, the atmosphere will expand again, and the ice will sublimate once more. But before that, we are witnessing a rare astronomical phenomenon, the compression and possible temporary collapse of the atmosphere. As the atmospheric pressure drops, Pluto's beautiful blue haze will gradually disappear. Surprisingly, Pluto's overall brightness may actually increase slightly because more of its surface will be covered by fresh, reflective frost. When New Horizons flew past Pluto's equatorial region, scientists discovered something completely unexpected. Dunes. That is right, dunes. Just like the wind-blown dunes on Earth, they are located at the boundary between Pluto's vast icy plains and its surrounding mountains. These dune features were confirmed in a 2018 study by Matt Telfer. These dune-like ridges appear in a region up to 46 miles wide on the western edge of Sputnik Planitia, which is Pluto's large, heart-shaped nitrogen ice plain, right where it meets the towering water ice mountains known as the Al-Idrisi Mountains. These dunes form parallel ridges that visually resemble wind-blown dunes, but here, the sand is made up of frozen methane particles. So how do dunes form in such a thin atmosphere? The surface pressure on Pluto is only 1 Pascal, which is just 100,000th of Earth's atmospheric pressure. The conventional scientific view is that Pluto's thin atmosphere simply can't lift or move sand grains. But Pluto has clearly found a way. During a Plutonian day, solid nitrogen ice on Sputnik Planitia sublimates directly into gas. In this process, nitrogen gas releases a large amount of energy. As this gas expands and rises, it temporarily lifts tiny particles into the air. Trowell and his team discovered that If methane ice grains a few hundred microns in size are lifted by this sublimation, Pluto's weak winds about 22 miles per hour are enough to transport these particles and gather them into dunes. The particles carried by these winds are most likely frozen methane from nearby mountain ranges. There are methane ice caps on those mountains, of course. They may also contain fragments of nitrogen ice. Because the surface geology of Sputnik Planitia is relatively young, the nitrogen glaciers are constantly flowing and renewing themselves. These dunes themselves are also likely to be relatively young. They may have formed within the past 500,000 years. The discovery of Pluto's dunes, it completely changed our view of this distant world. We once thought that a thin atmosphere meant Pluto was a dead planet. But in fact, the opposite is true. A thin atmosphere does not mean it is inactive. Mars also has a thin atmosphere, but it has carbon dioxide dunes. Saturn's moon Titan also has dunes made of hydrocarbon grains. Now, Pluto has also joined this group. This proves that even under the low pressure, extremely cold conditions of the Kuiper belt, planetary winds can still shape the surfaces of celestial bodies. After New Horizons left Pluto, it continued on toward an even more distant target, Arakos. On January 1st, 2019, the spacecraft flew past this small body at a distance of about 4.1 billion miles, giving humanity its first close-up look at a primordial Kuiper belt object. New Horizons discovered that Arakos is like a cosmic snowman, two irregular objects tightly fused together. The main body is about 22 miles long, with one side about 13 miles wide and the other side about 9 miles. It is a contact binary, formed by the merger of two separate celestial bodies. Images taken during the flyby revealed an astonishingly smooth surface, uniform reddish hue, and very few impact craters. In many ways, Arakos appears to be the most pristine and ancient object we have visited so far, one of the oldest bodies in the solar system. It is like a time capsule from the dawn of the solar system, preserving countless secrets waiting for us to uncover. But one of the most striking features on Arakos' surface is its large, hilly structures. These structures occupy most of the larger side of the object. The latest high-resolution image analysis shows that the larger part of Arakos, nicknamed Wenu, is covered by about a dozen broad mounds, each about 3 miles wide. Surprisingly, these mounds are remarkably similar in shape, size, color, and reflectivity. Almost identical. Will Grundy, a researcher from the New Horizons team, pointed out that Arakos almost looks like a raspberry made up of small units. This object is so well preserved that we can directly see its building blocks. These mosaic-like components suggest that Arakos formed in an extremely gentle process. Arakos formed in extremely gentle process areas. Arakos formed in an extremely gentle process. It seems to have accumulated gradually over time. Scientists believe these mound-like structures are locally formed fragments, originating from the same initial cloud of material. They are not shards created by violent collisions, but more like siblings that grew up together, gradually merging into a whole, based on Arakos' shape and chemical composition. Scientists have found a wealth of evidence to support this view. The two lobes of Arakos meet at a contact point. The poles and equators are aligned. This suggests that the two objects once orbited each other and gradually spiraled closer together. The lobes themselves are flattened, somewhat shaped like pancakes. This may be the result of their gentle merger within a rotating disk of debris. What is especially noteworthy is the uniformity of Arakos' surface composition and color. This suggests that its building materials most likely came from the same region of the solar nebula. If Arakos had formed through the traditional process of hierarchical accretion, meaning it gathered material from different places through random collisions, then we would expect to see much more heterogeneity. However, all the evidence points to a different formation mechanism, the cloud collapse model. In this model, a dense cluster of solid particles in the primordial solar nebula collapsed under its own gravity and directly formed a planetesimal, thus skipping the stage of violent collisions. William Meakin, co-author of the study, explains that Arakos particles clumped together at low speeds, orbiting each other, and eventually merged under complex gravitational forces. This discovery almost rules out the traditional hierarchical accretion theory and strongly supports the pebble cloud collapse model. It reveals a major breakthrough in our understanding of planetary embryo formation. Planetary embryos are the very foundation of planet formation. Apart from its unusual shape, the dark reddish hue of Arakos' surface is also remarkable. It hints at the chemical story of the early solar system. Spectral measurements from New Horizons show the surface of Arakos is covered with methanol ice and complex organic molecules, possibly tholins. We will explore this in more detail later. Surprisingly, no water ice has been detected on the surface. Water ice is common on many bodies in the outer solar system. Traces of water are even found on tiny comets and Kuiper belt objects. The absence of water ice suggests either the water is buried deep beneath the organic layer, either the conditions during the formation of this planetary embryo resulted in an extremely low water content. In fact, Arakos belongs to the group of ultra-red objects because its surface is rich in organics. Its reflected spectrum appears extremely red. This reddish material is believed to be rich in tholins. These are complex macromolecules. They typically form when cosmic rays and ultraviolet radiation interact with simple compounds like methane, ammonia, and nitrogen. Tholins do not indicate the presence of life, but they are prebiotic chemicals, containing many of the chemical building blocks of life. Under the right conditions, these blocks can become precursors to life's basic components, such as amino acids. The presence of frozen methanol became another clue to revealing Arakos's history. Methanol can form through the irradiation of water and carbon monoxide, or it may exist as a primordial ice, paired to gases like methane or nitrogen. Methanol is less volatile. Scientists believe that more volatile ices like methane, ammonia, and hydrogen sulfide once existed on young Arakos. But because Pluto's gravity is extremely weak and its surface is exceptionally cold, these volatile substances, over billions of years, either escaped into space or underwent chemical transformation. The presence of sulfur-rich thiokine compounds suggests compounds like hydrogen sulfide once existed and contributed to the surface chemistry of Arakos. As these gases dissipated or turned into solids, what remained was a layer of red organic frost and methanol ice covering the surface, as if this celestial body were coated with an organic veneer. Notably, there is almost no water ice on Arakos's surface. This could mean that water ice is buried beneath this layer of organic material. Because the region of the solar nebula where Arakos formed was extremely cold, water ice may have already gathered into larger bodies. In either case, the composition of Arakos suggests that the raw materials for planet formation are highly diverse. By studying these materials up close, scientists are able to catch a glimpse of the chemical environment of the outer solar system 4.5 billion years ago. These substances most likely arrived on Earth via comets and asteroids, and provided the key elements for the birth of life's components. Essentially, this lifeless celestial body preserves the organic chemical processes from the early days of the Sun's formation. It is like a frozen chemical time capsule, perhaps representing an initial starter kit for the origin of life. These discoveries, it makes one wonder, could life exist in Pluto's ocean? Is it possible for life to emerge there? If Pluto has managed to preserve a liquid ocean for billions of years, then it means it has maintained a stable water environment, which is crucial for all forms of life as we know them. This ocean might contain ammonia and salts, which not only act as antifreeze, but could also serve as nutrients. And if Pluto's core can provide heat and chemical gradients, it might offer an energy source for life, just like hydrothermal vents on Earth's seafloor. Of course, there is currently no evidence of life on Pluto. The New Horizons mission was not equipped with tools to search for signs of life. But even so, Pluto is far from the Sun. The fact that there are subsurface oceans in environments with scarce stellar energy still suggests that Pluto may be more suitable for life than scientists previously thought. One researcher once mentioned that if there is life in Pluto's subsurface ocean, then these life forms would be shielded from harsh cosmic radiation and able to avoid extreme temperature fluctuations. Such life forms, most likely, they are microorganisms. They obtain energy from chemical reactions in rocks and water. Although this possibility is slim, the question remains unresolved. Did microscopic life ever originate in this hidden ocean, or could it still be emerging here today? Perhaps only future missions, when they probe these deep, dark waters, will tell. Only then can we get the answer. New Horizons gave us a brief glimpse, a few days' worth of Pluto data, and just a few hours of Arakos data. Although the time was short, these observations completely changed our understanding of these distant worlds. Years have passed, but planetary scientists are still delving into this data, and we keep making new discoveries. Even so, many mysteries remain unsolved, or have only just begun to reveal themselves. For example, has Pluto recently experienced cryovolcanic eruptions? Is this activity still ongoing? As Pluto's atmosphere gradually thins and is replenished, how does the climate of this dwarf planet change? The existence of a subsurface ocean raises even more questions for us. Is it in contact with Pluto's rocky core, or is it sealed beneath a layer of hydrates? How thick is the ice shell? Is there liquid water near the surface? Are all cold classical Kuiper belt objects like this, or is Arakos a unique exception? To answer these questions, scientists are in urgent need of new missions and innovative research methods. Nowadays, there is growing interest in the scientific community in returning to Pluto. For example, NASA has already funded preliminary studies for a planned orbital exploration mission. Won't it be just a simple flyby? Instead, it will be a research project that can stay at Pluto and its moons for many years. This mission envisions the spacecraft will arrive at Pluto and enter orbit. It will create high-resolution maps. It will track the seasonal changes in Pluto's atmosphere. It may even deploy a lander or an impactor to analyze the composition of Pluto's surface up close. Since entering orbit requires significant deceleration, researchers are considering advanced propulsion methods. This includes efficient ion engines and even futuristic concepts like nuclear thermal propulsion. One clever idea is to use Pluto's largest moon, Charon, as a gravity brake. Research has shown that an orbiter could use Charon for several gravity assists. To not only slow down efficiently, it could even exit Pluto's orbit. This would minimize fuel consumption that would give the spacecraft a chance to cruise through the Kuiper belt and eventually head toward other celestial bodies. According to the proposed plan, the spacecraft would stay in Pluto's orbit for 2 years. It would use Charon's gravity to exit the orbit and continue on to other Kuiper belt objects. It could be another cold classical object, might even fly by another dwarf planet. If this ambitious plan succeeds, it will greatly expand New Horizons' legacy, turning a brief reconnaissance mission into a long-term journey of exploration. For now, NASA has already extended the mission through the late 2030s, and this lonely probe, it will continue to bring signals from the edge back to human ears, again and again, even crossing the boundary of the solar wind and stepping into true interstellar space. It left behind 2 names, Pluto and Arakos. Perhaps these names will be mentioned by future generations again and again, not because they are the farthest from us, but because they were once the most misunderstood by us. We thought they were the frozen, lifeless ends, but they prove that the boundaries of the solar system are far less silent than we imagined. Perhaps the real wonder has never been inward, but outward. Those secrets hidden in the cold shadows are still waiting for us to approach, and all of this is only just beginning.